Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell and today we're going to be doing part 2 of our lesson on triangles. Let's jump in. Okay, so let's talk about how we can classify triangles by the length of their sides. We can also classify triangles by the lengths of their sides. As I just said, we are going to be learning about equilateral triangles, isosceles triangles, and scalene triangles. And we will start with equilateral triangles. So you may have guessed from its name that equilateral triangles have 3 equal sides. You probably hear it when you hear equilateral. They have 3 equal sides. It doesn't matter how long the sides are as long as they are congruent or equal. Let's look at some examples. This triangle has 6 centimeters on every side. Same with this one, 2.5, and this one, 3. So those are equilateral triangles. Pretty simple. Okay, now isosceles triangles are a little bit different in that they only have 2 congruent or equal sides. And again, it doesn't matter which 2 sides are congruent, but only 2 and 1 is not. So look at these. 6, 6, 10. 5, 5, 3. 1.5, 1.5, 1 foot. So you can see 2 are congruent and 1 side is not. And that is the definition of an isosceles triangle. And the scalene is a triangle that has no congruent or no equal sides. All 3 sides are totally different. Take a look, 5, 7, 3, 8, 6.5 inches and 2 inches, 5 feet, 3 feet, 4 feet. They're all different measurements. That is a scalene triangle. All right, let's practice and see what you know about triangles so far. See if you can classify each triangle as an equilateral, an isosceles, or a scalene. You can pause the video if you'd like. All right, everyone, how did you do? Let's take a look at our answers here. Okay, number 1 was an isosceles triangle because it had 2 congruent sides, 7 and 7. Number 2 was an equilateral triangle because all 3 sides were the same, 4.5 inches. And number 3 was a scalene triangle because it had no congruent sides, 5, 4, 8 centimeters. All right, now sometimes you're going to need to classify triangles using both their angles and their sides. Let's practice some of these. This first one is what we would call a right isosceles because see the right angle here? There's your right angle, but it also has 2 congruent sides, 4 centimeters and 4 centimeters. So it's a right isosceles triangle. How about the next one? This one is an acute scalene. Acute meaning that the angles are all less than 90 degrees, and scalene meaning none of the sides are congruent. We've got 1.5, 2, and 2.5. Then we have an obtuse scalene, where one angle is obtuse, and again, there are no congruent sides, 7, 8, and 3. And finally, we have an obtuse isosceles, where we have one obtuse angle at 110 degrees, and 2 congruent sides, both 4 inches. So sometimes we need to classify using both criteria. All right, now what about this? Do you guys think that we can classify this triangle? I mean, we don't even have all the measurements. How can we classify it? Well, believe it or not, we can. Let me show you what I'm talking about. Let's look at, first of all, what we know. This angle 60. It's one of the 3 interior angles of the triangle. And this exterior angle is 120. That's it. That's all they're giving us. But don't worry, we'll get it figured out. Okay. Step by step, take your time, don't feel intimidated. The best thing to do is just start baby steps. Okay, first of all, we want to try to find as many angle measurements as we can because we want to say, what kind of a triangle is it? We have to put a name on it. So let's start identifying some angles and measuring some angles. Okay, what do we have? Okay, we're told this exterior is 120, this interior is 60. So let's start here. Angle B is vertical to the 120 degree angle, so it will measure 120 as well. What that means is if you look over here where this B is, that's going to be 120 because it's vertical to the exterior angle of 120 degrees. All right. Now, the angle adjacent to the 120-degree angle must make a total of 180 degrees. These two exterior angles out here on the side, that has to equal 180 because it's a straight line. So we could plug that red 60 in there. Okay, now keep in mind what you learned about vertical angles. If we know that this guy's 60, guess what? The diagonal opposite is going to be 60 degrees as well. So we've already come up with 1, 2, 3 angles just because we've remembered our vocabulary. Okay, so finally, we know all angles in the triangle must equal 180, right? So now we know this interior angle 60, this interior angle 60. What do you suppose that last interior angle is going to be? It's pretty simple. All you have to do, you add these two 60s together, and that's 120. We know we need 180. 180 minus 120 is 60. So the third angle will be 60 degrees as well. So if we have 60, 60, 60, all the angles are the same, it's actually going to be an acute equilateral triangle because all the angles are less than 90 degrees and they're equilateral and that they're all the same. All right, everyone, that just about does it for this lesson. Thanks so much for joining us, and we'll see you next time.